Our next speaker is Daniel Volmar from Harvard University, who will be speaking about computing as organizational behavior, rules, judgment, and the automation of bureaucratic decision-making from 1958 to 62.
Now for, is this on? Good, okay. Death and destruction. Okay. For 3 days in October 1960, 300 elite representatives of science, government, and industry convened for the 28th semi-annual meeting of the Air Force Scientific Advisory Board, where recent meetings had revisited such staples of post-war aeronautics and propulsion, as propulsion and guidance. This meeting would be the first of its kind because that fall the Air Force would activate the 18th installation in the Semi-Automatic Ground Environment, or SAGE, air defense system. The milestone had the ironic property of satisfying hopes while defeating expectations. The Air Force had once planned to roll out 46 sites by 1961, but the latest schedule cut the order to 36 and delayed construction through 1963. Moreover, the half-built computer network, as yet unready to repel Russian bombers, was already facing further curtailment due to the imminent threat of the intercontinental ballistic missile. While the plight of the SAGE program alone was enough to inspire urgency, it was no longer alone. What these men had met to consider was the final report of a prestigious study representing 9 months of work by 150 participants on 18 subsequent computer automation projects, most of them initiated within the last 2 years. Each of these big L systems, as they were called after a common suffix in their management codes, applied digital computers to vastly different problems that arose in independent organizational contexts. No one could yet definitely say how these state-of-the-art information systems should work together to further national strategic interests as a whole, nor how much they would cost. The 13-volume report of the inaccurately titled Winter Study Group, intended to present the first collective assessment of the programs in the Big L family. General Curtis LeMay, the Air Force's Vice Chief of Staff, addressed the convocation first. Quote, "Someday in the foreseeable future, one man may be called upon to make a decision within a few minutes that may change the path of civilization. He may have only seconds if we don't keep pace with the times. Our task is to stretch seconds into long minutes," end quote. And for the godfather of American air power, this kind of apocalypticism was rather banal, but as the consummate bureaucrat, LeMay leaned on his desk as much as his sword. Command and control systems, he continued, must be built to enable the human to command and control the forces. The mechanized processes of data collection, processing, evaluation, transmission, and display culminate in one all-important event, the human decision, end quote. Accomplished suitably, automation could actually magnify the exercise of individual authority instead of diminishing it, rescuing both human life and human agency from the perils of the missile age. LeMay's words prefigured many others spoken throughout the 3-day conference, which again and again commended the nation's or even the species' existence to digital electronics, in particular the digital computer, which a decade of studies and proposals had promoted as the best hope for survival. It was now being offered as the only hope. Every faction represented at the proceeding, whether military or civilian, manager or practitioner, shared LeMay's basic premise: computer automation, as these men envisioned it, could preserve or even amplify the agency of the individual in the face of unfathomably complex, rapidly evolving global crises. But it was emphatically not supposed to replace the human being, or more precisely, the properly constituted bureaucratic authority as the ultimate decision maker. Nevertheless, while broadly sharing in the spirit of LeMay's sentiment, the content of the study's final report displeased senior Air Force officials. The task of reviewing the Big L systems had led the participants to conclude that they lacked any sort of holistic coherence whatsoever, and that their task as authors was to rationalize, ex post facto, the existence of multiple computer automation projects idiosyncratically conceived, independently designed, and separately managed. In their opinion, this cacophony of design converged inexorably on a presumption of total nuclear exchange while increasing the risk that it might come about illegitimately, which is to say accidentally, unlawfully, or otherwise breaching the official calculation of the national interest. Without a decision executed according to the principles of bureaucratic authority, there could not be war, only killing. A crisis in command that endangered human reason as much as human life. By 1960, this stock phrase, crisis in command, had taken purchase on the premises of Lawrence G. Hanscom Field, the small Air Force installation that hosted the Winter Study Group, as well as that year's proceedings of the Scientific Advisory Board. Since 1947, the government leased plot in Bedford, Massachusetts, had evolved from a small field station supporting the radiation laboratory into a literal military industrial academic complex, the site of MIT's Lincoln Laboratory, its recent spinoff, the MITRE Corporation, the Air Force Cambridge Research Center, and over a dozen management offices with spaces allotted to nearly 100 private firms. That September, the Hanscom population exceeded 12,000, divided evenly between military agencies, universities, and business. Within the defense establishment, it could no longer be described purely as a source of skilled labor, but a powerful lobby in its own right. To the organizers of the Winter Study, almost all of them connected to the SAGE program, the idea of a crisis in command encapsulated their long and frustrating experience applying computer automation directly to the work of a military organization, which could change itself in response to the intervention of engineers, triggering intractable cycles of adaptation and counter-adaptation. The crisis in operational command capability is the result of a technological revolution in weaponry, claimed the final report. The planner and commander are confronted with both conventional and nuclear weapons, many forms of delivery, and extremely complex control, sensor, and weapon systems whose potential capabilities can only be gradually realized. But these capabilities have short useful lives before a new wave of systems comes into the field. The available decision cycle for war planning and force employment becomes shorter and shorter, but the consequences of these decisions are greater and greater. In a subsequent talk, W. Thornton Reed, a research scientist at Bell Labs, declared that the basic purpose of command and control systems is to match people to weapons. The significance of this observation lay in the fact that, quote, the requirements on command and control systems are also affected by the nature of the forces to be controlled and the strategy with which they are to be used. In other words, long-term strategic choices will affect the requirements for and characteristics of command and control systems that are developed, and these in turn affect the strategic choices that it will be possible to make in the short term. End quote. If the nation did not carefully manage the formulation and implementation of system requirements, then technical limitations, not the reasoned calculations of responsible decision makers, would bound the set of actions performable in a future crisis. Unfortunately, Reed spoke for most of his colleagues when he insinuated that the Air Force was, in fact, building strategy into the technological environment of the nation's highest decision makers. As products of a many-faced federal agency, the Big L systems were proceeding in almost total isolation, both from one another and from the national interest. Their untended growth had exposed the presumptuousness of an obsolete list of organizational priorities that now appeared unsuited to the impending era of missiles and satellites. Sheer automation, unresponsive to evolutions in strategy and diplomacy, might encourage political leaders to make an inherently dangerous snap judgment, this was their term, with the most dangerous objects on the planet simply because the instrumentation for more measured action did not exist. By the fall of 1960, the cry of crisis in command had spread beyond the community at Hanscom Field. On September 23rd, the general whose office sponsored the Winter Study had already outlined its conclusions at the Air Force Association's industry seminar, a public event accompanied by press releases and coverage in newspapers and magazines. Wide defense shift urge to ease command crisis, read the front page of the October 10th edition of the New York Times. Crisis already here, added for emphasis. The MITRE Corporation, which administered the Winter Study for the Air Force, even referenced the crisis of command in its fall recruiting campaign. To senior Air Force officials then, the meeting of the Scientific Advisory Board was an opportunity not to publicize the report, but to minimize it, and no uniform speaker on the agenda acknowledged the putative crisis in command. Indeed, 4 days after the Times article, a MITRE memorandum precluded study members from offering statements without permission. In November, Air Force Headquarters designated the report as a sensitive internal document and resolved to limit its distribution pending an evaluation, which ultimately decided to handle it as an inauspicious planning input instead of the call to action the authors imagined. Still, too many name brand experts whose goodwill remained critical to achieving the military's technology goals in general had participated in the study to bury it completely. And so to appease its retainers as well as the industrial partners who had lended their employees, the Air Force unceremoniously dumped a 30-page Bowdlerization, The Challenge of Operational Command, into the gray literature in March of 1961. Now, the military still controlled the media narrative too well to worry about public embarrassment over a recondite study report. Rather, the Air Force reacted against a transparent adventure into power politics, which aimed to advance, or at the very least sustain, the influence of the elite set of scientists and engineers whose interests aligned with the Hanscom complex. 10 years prior, very similar studies generated by members of the same set had pushed the Air Force ambivalently down the path towards SAGE. Given the ambiguity of that outcome, senior officials were not eager to see yet another elite study expounding fine ideals but lacking actionable conclusions repeat the folly on a larger scale. By its own admission, the Winter Study's contemplative tone actually represented a failure to fulfill its goal of formulating a conceptual master plan. A lack of master plans notwithstanding, the digital computer became a common tool of bureaucratic decision-making between 1958 and 1962, with the United States Air Force, the single largest computer user in the world, setting the pace. For the first time, computers could do more than displace established means for accomplishing the work of the organization, but also create new forms of work that had previously been unthinkable. Nevertheless, choices concerning the division of labor between humans and machines still implicitly followed the assumption of bureaucratic logic, whose obsession is providing the right people with the right information to make the right decisions at the right time. In fact, with the exception of some forgotten experiments conducted in the early 60s, America's military political decision makers were never asked to submit to the kind of laboratory studies of organizational behavior that helped inspire SAGE and other programs like it. As such, automating the decision-making function while maintaining its social legitimacy has been and likely will remain fairly difficult, even in cases where it is the executives who may be more prone to catastrophic misjudgment than machines or their operators. At the same time, whether artificial intelligences can or should replace humans within critical decision loops might be at least partially beside the point. If the organizational context in which humans decide is highly constrained by technological objects bound to the rules by which they were built or trained, then the ultimate agency may lie, perhaps unknowingly, with those who inscribe them. Now, this process is opaque enough when it occurs in public institutions. As social power continues to shift to the private sector, the proprietary assumptions of the past will more strongly guide the future, and historians must therefore account for the role of computing in organizational behavior. And I blazed through that quite quickly, but I don't think anyone will complain if we wrap it up a minute early.